firstly introduce Taya from STFC UKRI. Are you here in the room? You're right here. There we are. Perfect. Great. No awkward virtual connects or anything like that. You know how to work all this?
No, I don't at
Oh,
all.
you don't? Nor do I. So, no, I do. I think you can use this, and you can go next and back with that.
Next.
And
there's a bit of a delay.
There's a laser as well. Yeah.
Oh, okay, cool. How do I use the laser? I'm going to attempt it. Oh, excellent. Okay. Hi, everyone. My name is Taya, and I used to spend my days hammering rocks in muddy quarries. And now I help teams launch instruments into space. So I'm going to tell you a little bit about how I got here. So this is From Rocks to Rovers, how geology shaped my career in space project management. So let me first take you back to 2019. I was doing my integrated masters at the University of Leeds. And at that point, I had absolutely no idea what career I wanted to pursue. So if you do, then you're already one step ahead of me at that time. But during my degree, I was lucky enough to go on a year abroad at Western University. And during that time, I delved into the planetary science modules that were offered there. You could say after finishing my degree, still didn't have a job, so I had all the gear and no idea. But what I did know was I was interested in the space industry. Now, after graduating, I was on, I think, page 7 or 8 of Google, and finally landed across this job as a graduate project manager over at Rouse Space. Now, that's part of the wider STFC UKRI bracket. So that's the Science and Technology Facilities Council. And they offer a 2-year program as a graduate, so either straight from your undergrad or following a master's program, which is what I did. And at this point, I'd never heard of project management, but I thought, I'm bossy, I'm organized, I'm very detail oriented, and I love leading a team, so why not give it a shot? Now, during that time, I was also afforded a 3-month work placement up at the UK Astronomy Technology Centre, where I got to see all the old timey-wimey astronomy stuff, which was really super cool. And I also got to work on my first NASA project. Now, after getting the role 5 years ago, I spent 2 years on the grad programme working on projects with the likes of the European Space Agency and NASA. And they also paid for me to go through my project management qualification, which is accredited by the Association for Project Management. And all this was leading up to my promotion as a senior engineering project manager, which I'm currently sitting in. And during this time, I've had some really amazing opportunities to work with all sorts of teams internationally. And I'm one of the lucky few that has actually gotten to see my first instrument launch. So I went over to the Vandenberg Space Force Base in California earlier this year to see my first project launch as part of the Punch mission. So what does a space project manager do? My role in these projects is to ensure that they are delivered to 3 key things. Now, space projects follow a typical timeline from concept through to design, manufacture, assembly, integration, testing, delivery, and finally commission. And as a project manager, I need to make sure that it's delivered to 3 key things, those being scope, time, and cost. So I need to make sure that they're delivered to the project requirements, the deliverables are meeting specified deadlines, and all this is being achieved within the wider budget. Now, I do this through careful planning during the bid stage, gathering subject matter experts and drawing on lessons learned from previous projects, referring to budgets and risk analyses so that we can have a baseline as the project progresses. Following this, during the planning stage, I will also pull together a team of people from all sorts of engineering functions, whether that's mechanical engineering, software engineering, electronics, production, and the likes of that. And as the project progresses, we will inevitably encounter hiccups because no job is perfect. And it's my role to determine what the most suitable way forward is. Drawing on my previous experience, the experience of stakeholders on the project, stakeholder being just anyone that's impacted by the project or its product, as well as the project sponsor that overlooks the technical aspect. So how my geology background helps me today. I've already kind of told you how I got into it, but I've not explained why my skills that I gained at university directly translate to project management. Now, if you can think of the geology skills such as field logistics, pulling together a team, doing your course, your mapping abroad. I did mine in the Spanish Pyrenees, for example. It involves quite a lot of logistics, and that can really translate to space instrument planning. Data synthesis, pulling together the maps and samples from your fieldwork itself. I have to pull together many, many delivery data packs, meticulously organized for all sorts of reports, plans and things like that that get delivered as part of the deliverables, in addition to the hardware. Adaptability, once again, that fieldwork, very unpredictable, very, very many days spent in the cover of my map under pouring rain. And that's exactly how you have to be with space project management. You need to deal with issues, identifying, escalating, and resolving them as quickly as possible. And then finally, cross-disciplinary communication. You will have to engage with many, many stakeholders from many, many backgrounds and kind of adapt as you need to, whether you're doing hybrid or in-person events. And then finally, public engagement, which is the fun part of project management. Now, geology taught me how to manage chaos, and that's exactly what space project management is. As you can see, that's a picture of me in front of the 3-meter vacuum chamber that we have over at RAL Space. We actually have a more impressive one, which is 9 meters in the National Satellite Test Facility, which was commissioned earlier this year. Thankfully, I have been snuck in for a tour there. It's quite rare that that will happen these days, but if you let me know, we can try and make it happen if you're over in Oxfordshire at any point. But I've already kind of explained to you how I got into it. Now I want to explain why we do what we do and how geologists make great space project managers. University is a training exercise. You learn a lot of things around gaining valuable geological knowledge, but what you're unwittingly gaining is also many, many transferable skills, whether that's in data collection, teamwork, presentations, leadership, self-motivation, and kind of being part of a bigger picture. Think of the numerous times you've been part of a team collecting and presenting data to a specified deadline. I remember my fieldwork and coursework quite fondly, maybe not so much at the time, and the many times I had to herd my team like cattle. It seemed I was leading the pack a little too often, but I am someone who's very organised and meticulous, and I do admit that this was a role I was all too happy to step into. So what are the projects that I'm currently working on? As you can see, this picture is dated Monday this week because we finally got our final flight model in for its vibration testing. So you can see NVIS, or the electronics box aspect of NVIS, sitting on the vibration rig. And that's me along with the NVIS team over at RAL Space. Now, NVIS is a spectrometer instrument that's going on board the Rosalind Franklin rover, which you can see me pictured standing in front of here. Now, last year, I was lucky enough to visit the ExoMars rover operations control room over in Turin in Italy, another perk of the job. And I was actually asked to put my geological knowledge to use for the first time in the 5 years since I graduated. And what they wanted me to do was go to the Mars yard and select some samples that would work with NVIS and PanCam. Now, PanCam is literally just the rover head that you can see. And the point of the NVIS instrument is to give you the context that panoramic camera or PanCam provides. So I picked some samples and brought them back to the UK, and they seem pretty happy with that. Now, the fun stuff, also known professionally as public engagement. I've been lucky enough over the last 5 years to be involved in numerous outreach and public engagement events, such as the ones shown in the pictures. It's safe to say I've had a lot of fun at RAL Space outside of the project management side of things too. And for example, you can see me here speaking to Fredo, who is not animated, as appears in the picture, but is representing the Saxford Spaceport, located in the Scottish Highlands. You can see me and another project manager in the middle having fun in one of the 3-meter thermal vacuum chambers. No projects were harmed in the making. You can see RAL Space representing RAL Space at the National Space Centre in Leicester. You can see me here dressed up as an astronaut. No, they didn't launch me, but I was just helping one of the primary school events. And I said I'd chuck it on, why not? And then I must admit, I've had a chance to do some really fun things in my role over the last 5 years, but my proudest moment was raising the cup trophy for the first time ever as captain of the RAL Space Rounders team, fondly known as Base Invaders. And and this was, yeah, competing as part of 20 teams in the largest summer rounders league in the whole of Europe. And that's hosted on Harwell campus. So if there's anything to take away from this, it's that. In case any of this appeals to you, we have a list of graduate placements, internships, work experience, apprenticeships, industrial placements that all can be found on the pages here. So we've got the STFC careers page and the STFC LinkedIn. So I'll give you a moment to take a picture of those if that's something that you're interested in. Yeah. And it's just really important that when you are applying for these roles, you emphasize the skills that you learn whilst you're at university and how these can be applied / transferred to different job roles. This is what you should be focusing on. So looking back on the job description that I originally applied for, I had 2 things. One was the audacity and the second was a dream. And yet it paid off. So don't be afraid to apply to whatever you come across, whether you think that you fit even 20% the description of. And, you know, the worst they can say is no, and your life was the same before as it is after. Or they can say yes, and your life has changed forever. So if you love science and you love geology, but you don't necessarily want to stay in a lab forever, project management can be your launch pad. Thank you so much for listening.
Time for 1 or 2 questions, if anybody's got one. We've got a mic back.
Yeah.
The microphone coming right at you, so hold on.
Yeah. Do you experience imposter syndrome?
That's a really good question and one I get asked quite a lot. Is it quite narcissistic to say no? So I think in being asked that, I feel maybe I should do, but it was quite a natural progression for me. And my mum always taught me, you know, the worst they can say is no. And why not me in comparison to someone else? You can think that you fit a job description 100% and not get that role and be devastated. And you can fit 20% of it and get that role and think, okay, they saw something in me that I may not necessarily have seen in myself. So why not go for it? Why not trust them and trust that they've done this for years and years and years on end? You know, I wasn't the first graduate project manager to come to the group, and I definitely wasn't the last. So I need to recognize the fact that they saw something in me and work towards that. And that's what I've done ever since.
Thank you very much.
Other questions right here? Saw some hand up. One over there. Sorry, George, I have to run. On just a second.
I've spoken to John before, he can project.
That was an excellent talk. I was curious what you'd like to see in space geology in the future.
Ooh. Interesting. I'm really trying to think back to kind of my time at Western University. And John, I'm going to have to get back to you on that because I do have an answer for it and it's just not coming to mind right now.
Is it more space bodies?
Yeah. I was always really interested in the Martian side of things. So I think it's probably quite apt that I'm now doing a project that's going to Mars, even if I'm not involved in the geology side of things. But yeah, I'll think back and come to you with a better answer.
Perhaps in relation to that, to John's question, how do you see your career playing out in this?
Okay, so that's quite an interesting question. So RAL you know, really fortunate in offering career breaks, and I'd always wanted to travel to Australia. So I kind of set myself a goal of within 5 years obtaining the promotion of engineering project manager, senior engineering project manager, so that I would be able to go on this career break and kind of have a look at what roles are offered out in Australia before returning back to STFC UKRI. I'm really fortunate in that they offer quite a lot of support progressing towards chartership. So I think that would be my next step professionally, is becoming chartered by the Association for Project Management.
Any questions? Okay, thank you very much. Thank you very much. Very much appreciated. So second of our speakers this afternoon is John Pinot, who I'm guessing is you from the last question, who's going to talk to us about robotic and human space exploration. Thank you, John.
Thank you.
Controls there.
All right. Thank you.
Slides are up. You're good.
All right. Thank you for having me here today. And that was an amazing last talk, and I'll try to build upon that. There's a little bit of overlap, but we're definitely pulling in the same direction. And so, yeah, my name's John Pinot. I'm a space systems engineer, an aerospace engineer by trade, and I'm not a geoscientist by training, but I support scientists, and I'm a scientist at heart. So I'll talk about how geoscientists would be involved in the space industry today. So my background is where I started and got my passion was the dark night skies in America, in the middle of America, in Colorado, in the Rocky Mountains, and that got my passion for space exploration going. And what I talk about here today, though, is directly applicable to the similar pathways that you'll find here in the UK. I'll talk a little bit about my background, and then talk about how the industry is shaped, and then talk about how you can engage in the industry. So my start was through high school, a year of secondary school. They didn't really have the classes that I was interested in, and so I actually made my own independent study astronomy class, and got a telescope and did some side studies. So if you don't see what you need to grow your passion into a career, sometimes you need to ask around, and you can make it happen. But getting involved with clubs and societies there. I went to university for aerospace engineering, which is basically the application of a lot of other engineering types or the space environment. And the big takeaway there is try to get applied experience. So show wherever you go in your career, it's really important to show that you take that education and apply it somehow. So as projects or getting into the lab, writing research papers, and showing that kind of what you've been studying and getting that real world experience. For me, that was some internships, working in the lab in the university. My first job in 2000 was climbing around on rockets and helping design the Atlas V space rocket. But I also did payloads for the space shuttle and space station while at university. So there's different lab groups and different companies that are connected through universities that you can get involved with as well. I had a second internship with NASA Ames and did similar work and was able to test equipment before it goes into space, being weightless on this plane called the Vomit Comet by some, the KC-135 or Weightless Wonder by others. Yeah, a lot of fun. But yeah, there's you can think outside the box and getting this hands-on experience. Next, back to geology. The Mars Society has a Mars Desert Research Station and also has an Arctic station as well. And that's where we go out and study operations, geology techniques, and different other methods for how we're going to operate and work on the moon and Mars in the future. So something to keep in mind, and they operate, all through the year. Next is to think about how you start off in the industry. And being a scientist, the normal route is to usually get a PhD and work through a university or a research group, and then progress through research studies. But there's a couple other methods as well, going direct to the industry and working for a major aerospace company. Sometimes you get stuck doing the same thing for a long time in those roles. So I took a different path. I do aerospace contracting, and I've been with Stellar Solutions, a contracting group, for about 23 years. And that allows me to jump around and work for a lot of different companies, a lot of different roles, and not get stuck doing the same thing for too long. But back to the geology. As a planetary geologist, Mars is a prime candidate. There's a lot of research going on there, either for the orbiters mapping the surface, and then sending down rovers for in situ measurements. And this tells us about the history of Mars and how it evolved through planetary development. And also, we have some sample returns here from a comet, Wilt 2. We brought back samples from a comet back down to Earth, and we're studying those. And so, getting those data points of other materials from other bodies in the solar system. I'm going to fly through a bunch of other programs, robotic repair, gamma ray observatories. But back to the human space flight. We're at an exciting time right now. NASA's Orion's capsule is due to launch in April with a crew again. And that's going to rotate, it's going to orbit the moon and come back, hopefully. And it's been going on for a while, and we've been holding our breath for this. But we're getting closer to having geologists back on the moon. One of the last people to leave the moon was a geologist, Harrison Schmitt, I believe. And we're really looking forward to getting geologists back there and exploring the surface further. I did more electronics and avionics with that mission. I should say, I think I've worked something like 21 different space missions, all the way from design, development, test, integration, operations. And here, another big part of the industry here in the UK is earth sciences. And so mapping the Earth for weather, climate, surface geology, ice mapping to monitor and track changes is a really big part of the UK space industry. So more recently, though, I've been looking more at the outer planetary system, visiting small bodies in the solar system, thinking about how the solar system has developed, evolved through the last 4.5 billion years. And I help support geologists, scientists make up different requirements and needs for how do we study these bodies, and then us as engineers make those dreams come true and get those special science bits back to them. So I've been doing that for the last about 10 years and lead some of the exploration of these bodies. One of the biggest ones here in Europe was the Rosetta mission that orbited and observed the comet Churyumov-Gerasimenko. And here you can see it's a geologist's dream, right? You have a super complex surface, all sorts of different processes happening here. It's very active as well. We're flying through material, and so we're getting in situ measurements with the dust and gases, as well as from a lander that went to the surface. And yeah, just look at that surface for hours. It's so exciting, and to think about what it's been through. My current day job is the Lucy mission, NASA's Lucy mission. I should say I support this NASA mission remotely from here, from Oxford. I'm hosted both at the University of Oxford in the physics department, and then also at the Harwell Space Center, Space Cluster. And so this one will be the first to visit the Trojan asteroids that lead and follow Jupiter in its orbit. Here, these clusters, and those will tell us about the evolution of the solar system, which I don't have time to get into right now. But on the way, we're visiting a couple main belt asteroids. and then, several Trojan asteroids for our main mission. Let's see. The exciting part about this is it allows us to turn little points of light, unresolved bodies deep in space, into new parts of our solar system in a blink of an eye. We're flying by these objects at 15 kilometers per second differential speed. We have to plan our observations very carefully to get back the science that we need to analyze these bodies. So it results in something like this, not just a simple spherical rubble pile, but really complex surfaces that geologists are researching here today. This was our first test flyby for Lucy of Dinkinish. You can see it has a moon. Here's what a flyby of a small body looks like. We only could resolve the target for about 30 minutes, so we had to pack all of our science into that time. For the first time ever, we found a contact binary moon as well. That was a surprise. We didn't know it had a moon at all. So yeah, so we turn points of light into new worlds that scientists, geologists study. We had one more flyby this spring, a little bit bigger target, a little bit bigger team there involved. And we had another really cool object. Again, there's so much diversity in shapes and sizes and composition of these targets out there. I hope you follow along with the missions. Our first Trojan asteroid will be flown by in 2027. But think about a little bit more how you get involved with the industry is typically the geologists, geoscientists would be involved mainly with that first line up here, the sensors and payloads. This is how we investigate whether it's Earth, Mars, these asteroids and comets. It's how do we do remote science of these bodies. And some examples of those sensors would be, visible light cameras to look at the geological formations and topography, multispectral spectrometers to look at the composition, what sort of materials are on the surface, thermal imagers. This will tell us about the thermal inertia and how densely packed the surface is to think about how loose or compact that surface is. And then radar is another big one to probe the inner body some to understand the underlying layers. But the cool thing for the scientists is you get to be involved with all the parts of vehicle development because you set out that initial exciting question about let's go there and learn this. You then follow along with the team. Engineers like myself may come and go. We help out with a different phase, proposal, design, integration and tests, and then launch, and then operations. And so then the scientists have to be there at every step to make sure we're doing it right? Because you're the boss. We have to get you that special science back to answer those science questions. So what does it take? Pretty much most of the roles in the space industry take that base layer of software, computing, math, physics, and then you add your specialty science with that, your geology, biology, and other specialty things. Sure, you're doing that currently right now. And also to keep in mind, one mistake could lead to a mission failure. So it does take a lot of really attention to detail, teamwork, communication to make everything work just perfectly. You can lose millions to $1 billion with these robotic missions, but a human mission could be multi-billion in lives. So we all have to be pulling on the same rope. So does that sound cool? What does it take? Well, just to boil it down, study what gives you that passion and do that well, and to make sure you have a happy career and life going forward. But if you can apply it to space, it's pretty fun. But one thing that we heard about earlier, and I don't think you can say too much these days, is is things that don't matter are your gender identity, your race, sexuality, appearance, and where you come from. Come on, space exploration is for everyone. So how do we get engaged here in the UK? It's a lot of what I said, but to point to those specific locations. So to start off, you have your clubs, societies, and online materials, which are ever expanding. You can, I'll have this up in the last slide too, if you want to take a picture. But online materials, there's so much now. Universities get that base education and applied experience. And then it's great that you're here today with the workshops, specialized training and industry exposure is really great. The UK space clusters is a wealth of information now. You can see they're spread across the UK now with concentrations of space companies in different areas. We were both in the Harwell Space Cluster over here, and you can see a lot of information there. They have something called the Space Spinternships, which you can get involved with the industry with those opportunities. And then with the industry directly, a lot of times have internships as well. So I hope you follow along both with Lucy mission, Stellar Solutions, and again, those are the links for where to look for information for the UK Space Agency. Thank you.
Brilliant. We have loads of time for questions, so hands in the air. Any questions? There you go. Return the favour. Difficult question incoming.
Thank you, John, for that wonderful talk. So I know you said you have quite a breadth of projects that you've worked on, and with Stellar Solutions, do you get a choice of what you're going to work on next, and do you have any idea of what direction that's going to take?
Right. So within contract engineering, sometimes changes to contracts are your own choice, and sometimes not. It's sometimes based on budgets and needs, and basically we fill a gap of budgets come and go, and big companies need to weather when they have a lot of work and a lot of needs and big milestones, and they bring in help, and then sometimes they don't have as much budget and they get rid of people easily, right? And so it's a lot harder to get rid of employees, and so then we are a little bit more flexible. But also, if you see an opportunity, it gives you that flexibility to change yourself. I've changed from integration and test, software writing, avionics, electronics design, operations design. So if you have the background and confidence to change yourself and not get stuck doing the same thing forever, it gives you that opportunity to go and play on a lot of different things.
Thank you.
Yeah.
Yeah, thanks so much. Really interesting. I was just thinking in terms of data transfer, and this may not be particularly career specific, but so I work offshore quite a lot, and quite often it's quite challenging to transfer data from an offshore vessel back to onshore. I'm just thinking in terms of the somewhere out in the actual, how do you, or what sort of data volumes can you transfer back from some of these missions? Quite intriguing.
Right. Yes. So that's a big bottleneck for deep space missions, right? We have a limited number of deep space antennas across the world. 3 main sites, 30 to 70 meter dishes, and there's a lot of spacecraft that want to use those. And the rates depend on how far you are out. And I'm trying to remember, but some of those, like New Horizons, which I've worked on, went by Pluto, and it's 60 some AU out, and so we're working with kilobytes that we can bring back in a given certain number of hours. The round trip light time, I think, is something like 16 hours. So we're not doing anything at fly by wire. Everything's pre-programmed with everything pretty much beyond lunar, and lunar stuff will be pretty much we'll have a lot of autonomous stuff there. But yeah, we're talking the capabilities of the sensors are a lot better than what our data network can support. And so going forward, what the industry is looking at is laser comm. and there's demonstrations of those both here from the UK and with JPL. And they've done tests, I think, all the way to the lunar right now. And so the pointing accuracy has to be pretty tight, but yeah, it's going to afford a lot better data transfer. Yeah.
Thank you.
You talked about a geologist being in space, and I think the question in the back of everyone's head is, how do we get there? What would be a career progression from graduating from your geology degree to being
Yeah.
on the moon?
And that was my dream as well, right? That was my dream. And so how do you do that? And so it's changed a little bit through time, right? Initially, it was through the military, Air Force, and that route. But now a lot more of it is the flying of these vehicles is being more computerized, autonomous, and so it gives more route for the scientists and system engineers and people doing more experiments. So now there's a lot better route for space scientists, but that can take a lot of different shapes and sizes. That could be geologists, that could be biology scientists, and a lot of different other fields. And so I'd say what we've seen is get those base exploration science skills, whether it's working with cells, plant growth in space, life in space, space physiology, life support design, geology, and then do other things that help with that, because it's an international game now. Learn other languages. In the past, it's been Russian, right? Because it was a U.S.-Russian space station. Now with more lunar exploration, it's going to be a lot more European and American with current prospects, I'd say. But I mean, Russian's not a bad thing to learn, I'd say, in the space industry for this. Also, scuba diving and pilot license. So that's a lot of part of their training is being neutrally buoyant and controlling your body in a microgravity environment. And scuba diving is the closest thing that we can do, really. And then getting your pilot's license, because everyone's going to have to chip in somehow technically as well if you're flying. So whether you're a scientist or engineer. So those are kind of the side things, and I think you could probably find other recommendations, but combining these different skills. Yeah. So, yep, that was my dream too, but I'm now on to space robots, and it's just as exciting, and I didn't have to live in Houston, so. Yep.
Any other questions? So this is really remote geology, John. This is like as far as you can get from a rock. So you must have the occasional need to get closer to get your nose on a rock. How do you satisfy that in more terrestrial terms? Are there places you go to?
How does
geology?
Yeah, right. So people looking to do space geology, how do you get those skills here on Earth? There's workshops that some universities do. I know, I don't know them offhand. I know in the US some, but if you do a search, you should be able to find these. But a lot of times they do workshops either on Hawaii or other volcanic regions to look at volcanology, and that kind of mirrors a lot of what's going on the Mars surface. And then some caves, and then some Iceland, a lot of Iceland, very old rocks there, and a lot of geology field trips go up there to do sampling or autonomous UAV practice with sensors that they're building up to make for space flight usage but they're trying to get experience and develop that sensor on Earth. So they bring it to a similar location geologically here on Earth. So yeah, Iceland, Atacama Desert, more deserty areas, or volcanic areas like Hawaii. But there should be workshops out there that you can look into.
Thank you very much.
Yeah.
And actually, your last comments there make me realize I do have a connection with Planetary Geoscience. If you've been to our the shell table out there in the library, I have a couple of rocks on the table that are 500 million years old from Oman. And one of those has some very ancient but very well preserved organic matter in it. And when I was in Oman working those rocks for Shell, we had a research program with Professor John Grotzinger at MIT. He was in Oman wanting to study very early potential life on Mars. And John went on to be the chief scientist on the Mars Curiosity program. So geoscience really does get you everywhere, even me. So yeah. That's where we end this session. We've ended a few minutes early, but the next session is at 10 to 4, which is digital geoscience. So do come back into the room at 10 to 4, but otherwise go and get some refreshments and have a chat out there in the library. See you in a moment.